So great. Yeah, as already mentioned, so originally I was intended to present another session, but due to the latest service pack update or cumulative update, yeah, I mean, the session didn't work as before. That is the reason why I asked to change my session to another one, which is parallelism. I mean, it's a complete different topic, but still with regards to performance tuning. And I believe this is something which will still work. So yeah, that's the reason, yeah. Okay, so let's talk a little bit about parallelism. I will open Management Studio here. So everything what you're going to see from now onwards is really code and a real life demonstration. I do not have any other PowerPoint presentation other than my introduction. So what I did in order to prepare the session, let me go to the top here. Hopefully you can, I will maybe resize it a bit to 100%, otherwise I have to scroll so much. I hope it is still readable for you, otherwise give me a shout and I will resize it another time. Anyway, for the demonstration, I created upfront, I guess, 3 tables. You can see it's a pretty simple one. Yeah, create table test, column 1, integer not null. So I populate the table with a few records, create another big table, right? And there's another big table, just to have, I would say, at least 3 tables available, which are simple to demonstrate and have enough numbers or enough records in order to present parallelism. That's all. I did it already before the session because it takes, I don't know, 2 minutes or whatever to populate the tables. That's all. So honestly, I guess it's a little bit too small. So let me do this. So what is parallelism? Yeah, parallelism is yeah, it's really hard to explain, but I will give it a try. So in general, SQL Server have the opportunity to run your SQL Server queries in parallel. So there are a lot of dependencies, there are a lot of pre-requirements, so that SQL Server in the end selects the parallelism or prefers the parallelism, parallelized plan over the plan which is running in serial. So we are going through the pre-requirements in a minute. But first of all, I would say the overall summary is that parallelism is not always good. So honestly, in an OLTP system, so in a transactional system, in an ERP system, I would say, parallelism is something you should avoid. When you have a mixed or even, I would say, classic data warehouse, then parallelism is something which will definitely help with regards to the performance, with regards to the elapsed time, to be really precise. So, and therefore, you really have to understand and analyze your workload and have to understand the intention, the purpose of your database. It is, as always, there is not a clear, how can I put it, a clear statement. It really depends as often. Yeah. So the idea is that SQL Server uses more than one core in order to run your query, which again can be sometimes faster, but often it is slower because we have an overhead. We have a few SQL Server operators here, like I would say the guess is always the end of the parallel execution, which had its own overhead. We will see that there's a thread 0 to coordinate the parallel phase within an execution plan, which also have an overhead, right? And we will see that in most of the cases, again, it is not really helpful to have a parallel query plan within your OLTP system. So nevertheless, the pre-requirements so that SQL Server can at least think about parallelism is you have to have a multi-processor, multi-core, or hyper-threaded machine. I mean, that's normal. So the processor affinity configuration must allow SQL Server to use at least 2 processors for sure. The maximum degree of parallelism advanced configuration option must be set to 0, which is a default, or more than 1. So 0 means something which we will see later on. SQL Server can use all cores which are available, which is, I would say, really a bad idea. Yeah. Or you say you want to restrict the number of cores by setting the right number of cores in your advanced options, which is for sure the recommended way to do it. Then the maximum degree of parallelism configuration for the resource governor must also allow the use of parallel plans. So I will show an example where I use a resource governor in order to limit specific connections to use more than one core, which is really helpful. But it's an enterprise feature. So the resource governor is an enterprise feature. So, and the estimated cost to run a serial plan for a query is higher than the value which is set in a cost threshold for parallelism. And the last one, and again, I'm going to show all these kind of things now, but the last one is really, really important. The decision, or the other way around, before SQL Server even starts the execution of the query, SQL Server has to create a so-called execution plan. And everything which SQL Server decides is based on cardinality estimation, CPU available memory, and so forth. That means you can get a precise, so-called good enough plan, or you can get a good enough plan which is far away from being good. So, and that is the reason why you really have to think about what are estimated costs. We will see an example later on where the estimated cost, again, this is the decision for SQL Server to run a plan either in a serial fashion or in a parallel fashion, so that these kind of estimated costs are completely wrong. So which will lead to a non-optimal plan anymore, right? So it's an estimation. That is what I want to say. Estimation, nothing else. So first of all, let's try to understand what it means that a SQL Server have to have a multiprocessor or multi-core hyper-threaded machine. So there's one, I would say, very prominent DMV which we can use, which is DMO sysinfo. And when you ask, there are a lot of more columns, but I just want to concentrate on the 3 here. So we can see the CPU count is 8. We have a hyper-thread ratio of 8. And for sure, we have 1 physical core. That means my machine in front of me, which I'm currently using, have 1 CPU, 1 physical CPU, and has 8 logical cores. So therefore, I have a hyper-threaded ratio of 8. Okay, so that means in this case, SQL Server can already run a query with, and I really want to be precise, with n times 8 cores. So, and this is something which we'll also see later on, hopefully I have enough time, that SQL Server is not limited by 8. It is n times 8, which is completely different. Because if you have something like a stopping operator, like a hash join or whatever, where you have a build and a probe phase, so SQL Server will allocate at least 2 times n, which is, 2 times 8 threads, which is 2 times 2 times 8 thread, which is 16. When you have a merge, for example, which is not non-blocking, you will end up even with 3 times 8 threads, which is 24. So therefore, you really have to be careful to understand what is the impact of running a query in serial, in parallel, because it is not just 8, it is n times 8 threads, which SQL Server is going to allocate. And we will see that there is a specific number of maximum, so-called maximum worker threads available. And when SQL Server reach the limit, you have a so-called Threadpool Starvation. We will see this later on. Yeah, so this is also something you have to keep in mind. So what is the processor affinity mask? I will show you the processor affinity mask here. I don't know why it is flickering. I have no idea. But no worries. Maybe this is because of the GoToMeeting. So this is my physical CPU, which where I do not have a logical NUMA node on top of it. I do not want to make it too complicated. Consider a NUMA node as a physical CPU, at least on my machine. We have 8 logical cores, and this is so-called the affinity mask. And what you can do is you can set your affinity mask whenever you really do a deep analyze in order to understand whether it is worth to set a processor affinity mask which is different than the default. So the default is automatically set IO and automatically set processor affinity mask for all processes, right? Sometimes it makes sense to think about changing the settings here. For example, when you have another machine, another instance on the same host, then maybe it makes sense to think about I would say, separate the CPU, the cores which can be used by one and the other. It can make sense. Or when you have, I don't know, reporting services, analyzer services, or even I have a customer which is running SAP on the same host as SQL Server. So there it may make sense, to set the processor affinity mask to prevent that SQL Server can allocate all cores which are available. The problem is that often the other service which is running on the same host is not limited. So that means you always have some kind of a CPU contention, even if you set the processor affinity mask from a SQL Server perspective, right? So let me let me give you an example. So I just want to have need to make sure that everything is running. So I set the cost threshold for parallelism to 5, which is still the default, and the maximum degree of parallelism to 0, which means SQL Server can allocate all cores which are available, in my case, 8. So just to check whether everything is working, that's fine. So, and we can see we have 8 CPUs. So there is one configuration, well, there is a specific configuration which you can see in this configuration here. So, and there's the affinity mask and the affinity mask 64. So it depends how many cores you have. So you can see at least currently the value is in use. Value in use is 0. That means it is automatic. So let me do the following. I will run the first query here and will also display the execution plan. I don't know why it is flickering here. I have no idea. Anyway, so we can see that this query is running in parallel already. So we can see, for example, the number of cores which are allocated by this query here in the thread structs, for example. So thread reservation and use thread is 8. We will see this is not always the case. Sometimes SQL Server can reduce the number of threads when SQL Server detect CPU contention. I don't know when this feature was implemented in the engine, but I'm pretty sure it is fairly new, whatever fairly new is, but I remember the time that SQL Server wasn't able to reduce the number of threads when you have a CPU contention. At least in SQL Server 2019 and 17, this is the case, right? So when we have another thread here, reserved thread is 9. Maybe you wonder why you have one thread more than the use threads, because I have only 8 cores available. This is the so-called thread 0 or the so-called coordinator thread. We will talk about this later. Anyway, so what we can see here also is the estimated subtree cost. Subtree cost is 24. So because this is higher than the current cost threshold for parallelism, which is set to 5. Again, this is the default. SQL Server now compares the serial plan with a parallel plan, and for sure, based on cost estimation, based on cardinality estimation, and so forth, SQL Server now decides it is better, it is cheaper to be precise, not always better, but at least cheaper to run the query in parallel, right? So we can see, for example, the cost here, we can see the CPU time and so forth. So what I'm now going to do is I will set the processor affinity mask so that SQL Server can use CPU2, also the core, 2 only. So we can see this either from the GUI or we can also, you can see it here. So the processor affinity mask is set to CPU2 only. We will see this later on. That means SQL Server cannot use more than just one core, right? So we can see this here in DMOS schedulers, that for sure all other cores are still available, but they are not visible. So visible online, this is only true for CPU2. It means SQL Server cannot use all other CPUs because these schedulers cannot be used because they are not visible, right? Very simple. When I now execute the same select statement another time, it takes longer. Yeah, so you can see the comparison here. The comparison is already, well, first of all, let's go to the plan. We can see that this is a serial plan. We do not have a parallel operator anymore. You remember the gather stream and also the double rows. This is an indication of parallelism. We can also get it from the properties. Let me go down. And there's nothing about thread stats here anymore, right? Because there's only one thread which is used. So, but you can see already the reason why SQL Server is not or cannot use, in this case, cannot use. Sometimes it is SQL Server will not use, but in this case, SQL Server cannot use more than one core because it is set, or it will give you the information that the estimated DOP is 1, right? Which is right because the degree of parallelism is nothing else than the number of CPUs or cores which are available. Because currently there's only one core within my physical CPU available, that is the right information. So sometimes you wonder why your query is not running in parallel. It is a good idea, first of all, to check the properties, especially this one, in order to understand why this happens. I mean, we will see, no, we will not see, but I can already tell you there are some operators or iterators. It depends. So what I'm talking about is the physical representation here. So the instruction to the storage engine, what the storage engine has to do, is nothing else than the execution plan, which you can see. But some of the operators or iterators cannot use parallelism. It's impossible because of their implemented algorithm. So that means sometimes you will see queries which are much more costly than your cost threshold for parallelism, which is set to 5 in my example, but the query cannot run in parallel because of the limitations, right? I remember the time, and I'm pretty sure this is also still true, that a backward scan, so when you have an index seek with a forward or with a backward scan, I remember the time, and again, I'm pretty sure this is still the case, it's still a bug, that the backward scan cannot be run in parallel. So sometimes you wonder why your query is not running in parallel. So you have a lot of reasons why this happens. Okay, let me go down. So I will do the housekeeping just to ensure that everything is running, what I'm going to present now. And again, in order to make sure that really everything is running, I have to reset the cost threshold for parallelism, maximum degree of parallelism at the beginning of every execution. Just need to check this because otherwise it really it's not funny for all of us when I need to correct something later on. So that's perfect. So when I execute this example now, and I will do this in another session because otherwise it takes so long. I have a session here prepared where within the query options in the grid, I discard the result after execution, which avoids that SQL Server have to, I would say, I don't know what is the right word here, to paint the grid and also to populate the data in the grid, which is for sure much faster because I'm just interested in the execution, not in the data itself. So let me do the following. I will also enable statistics time and IO on. Not for this example, but later on, I will reuse the same session here. So it's almost here. It's already here. So again, we have a parallel plan with a hash match and a parallelism, a gather stream, which combines all the threads in the end before it is going to the select operator. And what I'm now going to do is I will change the maximum degree of parallelism to 1. So that's fine. When I execute the same query another time, it will take longer for sure. It's neglectable here because you can see I don't care if it, not in my example, I don't care whether it is a second or half a second. I mean, in an OLTP system, maybe this already matters, but nevertheless, we can see another time non-parallel plan reason is maxDB set to 1. And you can see that the estimated cost for sure is 110, which is greater than your cost threshold for parallelism, which I set to 5. But again, your decision is to limit SQL Server to use more than one CPU. We are talking about maximum degree of parallelism. You set it to 1, yeah. So that means, yeah, I mean it's right. SQL Server is not allowed to use more than one core, right? Even the estimated costs are higher than the cost threshold for parallelism. That is one way to make sure that your queries in an OLTP system cannot run in parallel. And believe me or not, SAP is doing it. So SAP, whenever you run a user query in SAP, so SAP or the recommendation and the setup from SAP is that SQL Server is limited by this setting, so no query other than the SAP queries can run in parallel. I mean, it's a very smart approach. So that means you have always all cores available, and you can all cores available, but at least you can run your queries in parallel when SAP internally executes query on the SQL Server engine. But whenever a user wants to get the best performance, maybe for data warehousing or whatever, the user is already limited by the setting. So that is really a smart approach from SAP. I like it. Yeah, it's really funny. So that they, in this way, they can avoid CPU contention, right? At least they can ensure that in SAP, everything is running fast, everything else is running slow. Okay. So, and this is, again, this is how SQL Server or SAP is doing it. So you can still, even that you decide to set the maximum degree of parallelism to 1, again, just one core, you can override the setting with a query hint. You can say option maximum degree of parallelism is, I don't know, 0 or something which is greater than 1. Then you're allowed to run the query. Oh, sorry, I will execute this one in the other session as well. Otherwise, it really takes too long. So we can see here that this time, even we set the maximum degree of parallelism on an instance or on a database level or on a resource governor level. So we have different kind of levels where we can set this as a property here. Yeah? So it is limited. It is not limited by the maximum degree of parallelism anymore. So we can see it is running with 8 threads. Yeah. And that can be a very smart approach in order to avoid that you're running in CPU contention in your system. So let me do the following. And for sure, I can do the other way around. I allow SQL Server to use all cores, but I can also limit this query, for example. I'm always doing the same error. Sorry, I need to switch to the other. Okay, it's here. So I can limit the maximum degree of parallelism for a query to 1. So therefore, SQL Server has does not have the possibility to run this query in parallel. Even the estimated subquery costs obviously are much higher than the cost threshold for parallelism. Okay, so you can, I do not want to go through the example here. I just want to tell you that there is also a database scope configuration, which you can get from here. Again, I do not want to display this, but that means you have an instance setting. Yeah. So that means every database inherits the setting from the instance, or if it makes sense, and often it makes sense, you can set the maximum degree of parallelism, I guess since SQL Server 2016, I didn't remember anymore, to be honest, but it is, yeah, it is a feature which was introduced very late in SQL Server. So you can limit the maximum degree of parallelism on a database level, which is really helpful. Right. So again, I do not want to go through this example because in the end, you will see it behaves exactly the same. You will overwrite always the instance settings by the database setting. Yeah. So database setting will always win. Okay. Now let's talk a little bit about resource governor, because I have a lot of customers with yeah, or the other way around. Whenever a customer calls me, a customer have performance issues. And so there are several ways. I mean, we are talking about parallelism in this session. So there's so much more which you have to do in order to make sure that your query or your SQL, it's not the query, it's the overall workload of your SQL server is running fast, right? But when it comes to parallelism, sometimes you want to ensure that specific connections, specific sessions, and a specific workload which is associated to the connection can use, I don't know, 8 cores or just 1 core, but all other queries running in another connection, yeah, can use 1 or 8 cores. So you want to distinguish the maximum degree of parallelism based on your connection, right? It is really helpful because, again, you always have to keep in mind that there is a limited number of threads available. We will see this later on. But if you reach the limit, all queries have to wait. You will see this. Yeah? So you have a so-called Threadpool wait start, which is Threadpool Starvation. So every single task is now waiting for an idle thread in front of your scheduler and cannot be executed because no idle thread can pick up the work. It's a task, all right? So, and therefore, it is really, really handy to use resource governor in order to reduce the CPU contention here. So, and what I'm going to do is I will create a so-called resource pool where you can set a lot of, the other way around. A resource pool is a set of resource settings. You can see it here, for example, minimum CPU percent, maximum. You can you can set also a few more. And you have a so-called workload group. So one workload group can have one, is associated to one resource pool in the end. But a resource pool can be shared across different workload groups, right? So I set it to maximum degree of parallelism to 2, so this workload group, and now I need to reconfigure the resource governor, right? So then we have a classifier function, which we have to use in order to, and there's only one. You cannot have more than one. So in order to tell SQL Server which or when a specific connection, or the other way around, when a connection is established, which resource pool, which workload group this session is going to use, right? So let me do this. So create classifier function. So pretty similar. It has to be schema binding, yeah, and can return in the end the name of the workload group. That's the idea. So, and the idea here is if the username is test my workload group 1, then set the workload group, which will be returned by the function to my workload group 1. Pretty simple. So you can do a lot of more. You can think about within, I don't know, 8 p.m. Or between 8 p.m. and 6 a.m., yeah, all connections can only use, I don't know, 4 CPUs or whatever. There are a lot of opportunities here. So let me create the classifier function. And now I will apply the classifier function by also reconfigure the resource governor. So now I need to have a login for sure. This is a login which I use here in my, where is it? Sorry, in my classifier function, right? Yeah, the username. So let me create this one. It's already there, perfect. And I also add the new user or the new login to the sysadmin role. Yeah. So what you can do now is the following. You can see that we have DMVs available in order to reveal all these kind of settings. So we have a resource pool, which is associated to the workload group, maximum degree of parallelism set to 2, effective maximum degree of parallelism is also 2. So when I now run another session, and what I will do here is I will use the other or the new created login, which is here. Let me do this. Yeah. So in this case, I can see that. Second, I will also change or switch to AdventureWorks. So I'm currently logged in as test my workload group 1, and I can see it's in master. No, it was a little bit too quick. Anyway, so we can see that this session is currently allocated to my workload group 1. So you can see the session name here, so spit 82, the workload group, and the association again, and the test login, the test my workload group as a login name. So what I'm going to do now is the following. I will execute this query in this session, and for sure within the workload group. So you remember this workload group is limited to a maximum degree of parallelism of 2. And let me also display the execution plan. And by the way, what I will do for the next execution, in order to save some time, I will discard the result. Okay, anyway. So what we can see here, in the query is running in parallel, yeah, but not with 8 cores or 8 threads, instead only with 2 threads. This is because of the configuration of the workload group, which is associated to the connection. Yeah, so there is a bug. I'm pretty sure this is a bug. Let me do this. I will set the workload group, yeah, and I will only allow the workload group to use a maximum degree of parallelism of 1 now, which means I cannot run a query in parallel. Yeah. So when I now reconnect, and I need to reconnect because the session setting is not going to be changed until I do it. Yes, I think that's already more than enough. When I execute the same query another time, we can, okay, it was a bad idea because I cannot show you the result. Anyway, I'm now connected with the workload group another time. And when I execute the same query as before, you will see that this time it takes a little bit longer. Even you limit the maximum degree of parallelism for this workload group by 1, you can see a parallel execution plan. And this is a little bit strange because the thread statistics, this is branched, not the thread statistic, right? You can see here that you do not have a parallel plan in front of you. I'm pretty sure this is a bug. I mean, it's a visualization bug, yeah? Do not worry about this. In the end, the query is not running in parallel, even you see a parallel execution plan, right? Okay, let me do some housekeeping. And let's go down. Let us try to understand the cost threshold for parallelism, so the impact of this. So I will reset the cost threshold for parallelism to 5 just to make sure that everything's working. Perfect. So I use the AdventureWorks another time and execute this query in this session. Is this the one? Yes, this is the one which I can use just to discard the results, nothing else. So we know already that this, for sure, because of the hint, maximum degree of parallelism is 1. This query cannot run in parallel, right? So perfect. We have the same cost as before, 29. Perfect. So And because I set the maximum degree of parallelism to 1, there is no chance that SQL Server can run this query in parallel. Normally, the query or SQL Server will decide to run this query in parallel for sure, because the cost of 29 is for sure greater than the serial cost, the estimated cost, which we still can see here. So the base for the comparison is always the serial plan. What does it mean? So first of all, I will execute the query here, where you can see that this time SQL Server prefers to run the query in parallel. Perfect. And the cost is a little bit reduced to 21.969. So what does it mean when we know that SQL Server now have to compare the estimated cost of the serial plan with the estimated cost of the parallel plan? This has an impact. So let's try to figure out the impact here. So there is another query here, which I'm going to use to use for this demonstration, because it is a little bit more complicated. The other query is pretty easy. You have only one join, and the number of, I would say, so-called memos, the plan alternatives, which SQL Server is going to compare to find the so-called good enough plan, is called a memo, right? So I'm talking about memos. It's in memory, I would say, structure for sure. So I do not even need to execute this one. I just need to include the live queries, but okay, I'm pretty sure it will not take that long. So I can give it a try. Yeah, it's already here. Okay, perfect. So this is a plan, right? So I limit the maximum degree of parallelism to 1. That is the reason why we only can see a serial plan. So there is a trace flag which you can use, 8675, in order to see the so-called query execution optimization phases. So we have 3 starting from 0. That means the end, or the last query execution phase is 2. So 0, 1, 2, 3 phases. So when you can see it here, you have search phase 0, which is the first optimization of the query. When SQL Server now internally does not reach the cost threshold for not the cost, the estimated costs, which is associated to the plan which is found within a given time threshold, SQL Server automatically will use search phase 1 in order to further optimize the query. And this optimization for sure is not for free. You have to pay CPU, and you have to wait for several additional iterations to find a better plan, hopefully. And if you reach the limit, the internal limit, SQL Server stops to optimize. But in this case, the query is so costly that SQL Server even spent another iteration, another search phase 2, in order to further optimize the query with more algorithms, which are more costly, which takes more CPU. And you can see in the end that search phase 1 and 2 is, or search phase 1 and 2 is there only one time. You can see the CPU time and a lot of more information. So the costs which are associated to the plan which is found and so forth. You can see, for example, search phase 0 give you an estimated cost of 24, but then it is reduced by 9 and another time by 9. Okay, now let's try to understand what it means. So I can get the compile time in millisecond and the compile CPU time in millisecond, at least from the cache plan. There are several other ways to do it, but sorry. This is because the execution plan is different, or not the execution plan, the query hash is different. Let me do this. As sometimes it will change. So the query plan hash, I'm pretty sure that is the one which I'm going to replace. Query plan hash. Why am I not getting back anything here? Just 1 second. Let me do it another time. It's still not working. 1 second, 1 second. If it is not working, I will skip this one. Yeah, it is for whatever reason, it's currently not working. Anyway, you understood already that CPU is used in order to optimize the query. What I'm going to do now is I will run the same query another time, but I do not limit SQL Server by a maximum degree of 1. That means SQL Server is very likely, because we know already the estimated cost, SQL Server will take more than 1 core. So this time we can see a complete different plan. We have parallelism and so forth, right? Because so the estimated cost is higher than the cost threshold for parallelism, which we can see here. The cost is now down to 8. But what we can see here from that perspective is that the search phase 1 is here 2 times now. Why? Search phase 1 is the first time that SQL Server considers to run the query in parallel and compares a parallel execution with a serial execution plan. In order to do so, SQL Server have to introduce and run the search phase 1 2 times, which means you will spend a lot of more CPU times when you compile your queries which are running in parallel, because you always have to compare the serial with a parallel plan, which takes another search phase 1 optimization, which takes time, which also takes CPU. So nothing is for free. And even if you just compile the query, you will see it. And I don't know if it is working now. Let me give it another try. Otherwise, I will skip this, because in the end, you will only see it's not working. I have no idea why it's not working anymore. But no worries. In the end, you would see the compile time millisecond, which we can, by the way, we can also get it from here. We can see it from here. So compile time is 20 milliseconds, right? And before it, believe me, it was 13 or 14, right? So nothing is for free. Let me go back. So I want to skip this one. Let me go to the starvation. So I have so much to present, because parallelism is definitely not a very easy topic. So what is Threadpool starvation? So I mentioned this already several times, and hopefully I have enough time to present this. So again, we understood, and I mentioned this already several times, that there is a limited number of workers available, 576, which is dependent on my CPUs. So the more CPUs I have, the more maximum worker threads I get. This is not proportional. You have to pay, because CPU is licensed, you have to pay a lot more to get more worker threads. That is the reason why you always have to think about parallelism. The more queries which are running in parallel at the same time, the less worker threads are available. The more it is likely that a query has to wait because there is no idle thread available. That is the problem about parallelism. That is a problem about the, I would say, the limitation which you have with your license. For sure, you can override this, but believe me, this is not a very good idea. I had one example. I had one customer who was thinking he is smart enough and he can cheat SQL Server by setting the maximum worker threads to 999 or whatever. In the end, nothing was working anymore. And just one hint: when you have availability groups, just the existence of an availability group will allocate CPU worker threads. This is something you have to keep in mind. I have a customer with 200 availability groups in one instance. When you open the log, the error log, SQL Server error log, and he only starts the machine, he's doing nothing. SQL Server already complains about Threadpool starvation. Yeah, so let me introduce this to you. So in order to demonstrate Threadpool starvation, I reduce the maximum worker threads. I can do the opposite. I can increase the workload, but this is easier for me to demonstrate because internally I have some limitations here. Yeah? So I can only run, I guess, 300 or 400 queries at the same time. That means I'm limited by O stress, to be honest. Nevertheless, so there is a limit of maximum worker threads available, 128 or 500 or 900. There is a limit. My limit is now 128. So you can see the maximum worker thread is set to 128. So I will set the cost threshold for parallelism to 5 another time. And just to make sure that everything is running, yeah, perfect, maximum degree of parallelism is set to 0. That means SQL Server can get as much as possible CPU cores. So this time I'm forcing a serial plan, and I will do it here. So, and this is the execution plan. For sure, it is running in a serial manner. Yeah, okay, it's not perfect, but that's okay, because it's not perfect because the estimated subtree cost is already 47, right? The problem for sure is a missing index, but nevertheless. So I will reset the weight statistics, and what I'm going to do now is I will run this query in serial, CMD, run as administrator. You can see it here 80 times, and no, 2 times with 80 concurrent threads. Threads. I do not want to confuse you. Let's say we are running the same query 80 times in parallel. Yeah. Okay. So what we can see now is I can get the request details to see what is going on in the background. So I can see a lot of sessions which are established, not a lot. One second, is this, okay, it's still not running. Should run. Begin. Oh, that's nice. 1 second. Did I do something wrong here? 20, it's adventure. Select all things, there's already a small order. Should run. What is the problem? Is the target server is running SQL Server, or does normally that something is going wrong here? This is now odd. Okay, so I will skip the demonstration because there are only 3 minutes left. Nevertheless, what we will see is that for every single execution, for every single query which is running in parallel, we will see for sure 1 session, and the maximum degree of parallelism, you can see it here at least, yeah, so is set to 1. Okay, so because the query only allocates 1 thread, I can easily run 80 queries in parallel, because all of these queries will not allocate more than 80 threads, yeah, at one point in time. So I do not have any problem here, right? So there's another DMV which we can use, and for sure I can show it to you, but not with the query which is running in the background. Nevertheless, it would exactly look the same. So we have a worker queue count, which tells you how many current worker threads, or to be, yeah, I would say it is a task. The task is waiting in front of the schedule for an ideal thread. So there is no queue, right? So again, if I execute the example another time and it would work, we will see exactly the same. There is no queue. From a weight stat perspective, sorry, there is no thread pool, there is no CX packet. I mean, CX packet is class exchange packet, which means it only measures the time a query will be executed in a parallel fashion. That means once you have once parallelism started and once it is ended by the so-called gather stream, this is the time a CX packet, class exchange packet, will collect for you. So CX packet is nothing which you should worry about. It will only tell you that your queries are running in parallel, because they are running in, the reason why they are running in parallel is because they are too costly. That's it. Nothing else. So I have I read a lot of articles, blog articles, where people are trying to tell me CX packet is bad. No, it is not bad. It will only tell you the time SQL Server, I would say, executes a query in parallel. But when you see it with the combination of thread pool, then you have really serious problem. So anyway, let me do this another time. I will execute this query, and hopefully this time it works. I mean, also from a CMD perspective. So this time I allow SQL Server to run this query in parallel, and we can see perfect, it is running in parallel. This time we will allocate a threads, which we know already. So thread statistics 8. So hopefully this example is going to work now. Otherwise, I will tell you what you should see, because honestly, I cannot see the reason why it shouldn't work. But okay, let's give it another try. It's really funny. I already presented the session several times. Every time it works, but for whatever reasons, some of the examples are not working anymore. Okay, let me try to execute this one. And I know that I'm almost done with my session. Nope, but it is not running. I'm pretty sure I get the same. I don't know if the target server is running SQL Server. I have no idea why this is coming up. Anyway, so when I execute the query, we should see the following. That I mean, it is for sure not perfect, but you will see that the request degree of parallelism is 8 in most of the times, because I allow SQL Server to run the query in parallel. But sometimes it is 2, sometimes it is 1, sometimes it's something between 1 and 8. That means SQL Server is already smart enough to detect memory or CPU contention. The problem is here that, I mean, this is an algorithm. In the end, we will see that we have a so-called worker queue starvation here. So this should be set to 1 or I don't know, 10 or whatever. That means the queries are waiting for an idle thread. They cannot even be executed because no CPU can take the work, can pick up the work. And therefore, we should see something like, not in this example, because you understood that the example is not working, we have Threadpool Starvation in combination with CX Packet. So in order to summarize the overall session, CX Packet is not for free, right? There is one last example, 1 minute. I need 1 minute really. So you can see the degree of parallelism here from 1 to 8, and you can see the elapsed time. And in an OLTP system, what you can see here is that the more CPUs you take for a query, the longer it takes. And the reason is CX Packet, the overhead which is related to this. And again, CX Packet is very likely that in an OLTP system, when your workload increase, that you will also run in a Threadpool starvation, and then you're really in big trouble. So you can reduce the maximum degree of parallelism. You can increase the cost threshold for parallelism. You can use resource governor. You can make sure that the query has the right index. There are a lot of ways in order to increase the performance and decreasing the queries which are using parallelism. So that's what I wanted to show. Sorry that the last example was not going to work. I have no idea. I need to check this because again, it was running several times already, but again, for some reasons, not today. Any question? Classifier function has a performance impact on small batch queries. It will be executed for each query. Yeah, no, it will be executed for every single connect. But once you have a session established, for sure, this classifier function is not used another time because it is the connection which is analyzed. And once the connection is established, there is no need to run the classifier function another time. But you are right. In general, you shouldn't have a complicated and a costly classifier function in place. But the one which I presented, for example, is pretty easy and really cheap. So, no, any other question? No other question. I will stay here for another 2 minutes or whatever until the next speaker arrives. So feel free to ask.